A database is simply an organized way to store and retrieve information. Instead of hunting through scattered spreadsheets or files, everything lives in one structured place. The software that manages that storage and lets you ask questions of your data is called a Database Management System, or DBMS. In this course, you'll learn SQL, the universal language used to talk to nearly every major DBMS in the world. Relational databases organize information into structured tables that talk to each other through keys, eliminating the need to duplicate data everywhere. Think of a customer table linked to an orders table. You store each customer once, then reference them from as many orders as needed. This connected structure is what gives relational databases their power and flexibility. We'll use SQLite with DB Browser, a free tool that requires zero server setup. Just download, install, and open it like any other app. Once you create a new database file and run that select statement in the SQL editor, you'll instantly see your first query result. If that greeting appears in the results panel, you're fully set up and ready to start building real databases. The select statement is the foundation of every SQL query. It tells the database which columns of data you want to retrieve. You follow select with the column names you need, then from to specify which table to look in. Using the asterisk wildcard grabs every column at once, which is handy for exploring a new table. The where clause lets you retrieve only the rows that match a specific condition, so you're not stuck reading every record in the table. You can filter text with equals signs, numbers with comparison operators like greater than or less than, and stack multiple conditions together using and or. Try running each example above and notice how the result set shrinks as your conditions get more precise. The order by clause lets you control the sequence of rows returned by your query. By default it sorts ascending, but adding DESC flips the order to largest or last first. You can even chain multiple columns, so when two rows tie on the first column, the second column breaks the tie. And, or, and not are logical operators that let you build powerful filters by combining multiple conditions in a where clause. And requires every condition to be true, or requires at least one to be true, and not flips a condition to exclude matching rows. When mixing these operators, always use parentheses to make your logic explicit and avoid unexpected results. Between lets you filter rows within a range. Both endpoints are included, so between 10 and 50 catches 10 and 50 as well as everything in between. In is perfect when you have a specific list of acceptable values, replacing a long chain of OR conditions with something clean and readable. Together, these two operators make your where clauses shorter, clearer, and easier to maintain. The like operator lets you search for patterns inside text columns instead of matching exact values. The %sign wildcard handles any number of missing characters, while the underscore wildcard stands in for exactly one character, and you can mix both in a single pattern to get very precise matches. Aggregate functions like count, sum, avg, min, and max collapse many rows down into a single summary value. When you add group by, SQL splits the table into groups first and then applies the aggregate to each group separately. The having clause is like where but for groups. letting you keep only the groups that meet a condition after aggregation. Group by collapses all rows that share the same value in a column into a single summary row, letting aggregate functions like count and sum do their work per group. Think of it as sorting your data into buckets and then doing math on each bucket independently. The golden rule to remember: any column you select must either be the grouping column itself or wrapped inside an aggregate function. Wherein having look similar but work at different stages, where narrows down individual rows before any grouping happens, while having filters the summarized groups that group by produces. Think of having as a where clause specifically for your aggregate results, letting you keep only the groups that meet a condition like a minimum count or total. A foreign key in the orders table points back to the customers table, creating a real relationship between the two. When we use a join, SQL follows that link to stitch matching rows together into one result set. This is the core mechanic behind almost every multi-table query you will ever write. An inner join connects two tables by comparing a shared key column. In this case, customer_it appears in both tables. Only rows where that key finds a match on both sides make it into your results, so any customer without an order, or any orphaned order record, simply won't show up. This makes inner join perfect when you only care about data that has a confirmed relationship on both sides. Unlike an inner join, a left join returns every row from the left table regardless of whether a matching row exists in the right table. Missing values simply show up as null. A right join does the same thing but favors the right table instead. In practice, left join is by far the more common choice because it lets you find gaps, like customers who have never placed an order. The insert into statement is how you add new rows of data into an existing table. You list the column names you want to fill, then provide matching values inside the values clause. Order matters, so each value lines up with its column. You can insert one row at a time or stack multiple rows in a single statement, which is faster and cleaner when loading several records at once. The update statement lets you modify existing records in your table. You use set to specify which columns to change and their new values, and the where clause targets only the rows you want to affect. Always double-check your where condition before running an update. Leaving it out will override every single row in the table. The delete statement removes rows from a table, and the where clause is your safety net. It tells the database exactly which rows to target. Without a where clause, delete will wipe out every single row in the table, so it's a best practice to run a select with the same condition first to confirm what you're about to remove. Think of it as double-checking before you throw something away permanently.